Okay, page 35, electric field patterns. In the last part, A and B, part A and part B, we know that what is the meaning of electric field. Okay, now in this session, we will focus on the pattern of it. Now, look at this one. Electric field lines. It means that this. Okay. This one will be the lines, but how to find out this line? We should focus on this original pattern. This pattern, how to construct it? We will think that we will put the test charge on different position and then find out what will happen. What is the force acting on it? In this case, should be the actual force. And how about the amount of it? Depends on the position. We can draw the line to pass through the position of it. Finally, we can construct a line. This line may be a straight line, may be a curve, depends on the pattern. Okay, now look at this. Lines with arrows to show that the field. Combine all the information together in different positions. We combine all them together, we can construct the field lines like that. And also, you should write down the arrow to show that the direction of it. But what is the meaning of the direction? It means that if you put the positive test charge here, it will follow this line. Okay? If you put negative charge here, it will move in opposite way. Okay? Then if you do it like this, you can draw many lines. This line, we will say that field lines. Combine all the field lines together to form a special appearance. Then this one we will say that field pattern. Now this, you put positive charge, point towards the direction of the electric field. Negative charge should be in opposite direction. And how to know that the field, the strengthness of the field, a stronger field? You should look at this. Will be the denser the field lines. How to know that? Look at this. A weaker field. If you use the same area, this area usually we will call it unit area. To find out how many field lines pass it. Okay, for example, in this case, only one field line. But if you put it near to the point source, then the same unit area, there are 3 field lines pass through it. Then we can say that here will be stronger field because the number of lines passing through the unit area is greater. Okay. And how about this? Exactly the same, only the direction of the field lines are not the same. Once again, the conclusion. More field line you can find it out will be stronger field. In this session, the field patterns usually will be formed by a point charge like that. Single point charge. It means that in the world, in the universe, only one charge. Then this charge will have electric field. This field pattern will extend to infinity. Okay. Positive one, the field line should be pointing outward. But why? Because if you put test charge, this test charge must be positive. Then they will have the repulsive force to move away from the center of the positive charge. On the other way one, if this one is positive test charge, this one is negative, it will have the attractive force. Then the direction should be in this way. Field lines show the direction of the force on positive test charge. Once again, test charge should be positive because this one should be the same direction of the electric fields lines. They start from positive and then end at negative. Here, charges of different magnitude. Greater charge, then what will happen? You should do the comparison. this one only Q, the other one is double of it, then the strength of it should be greater. But how to represent it in graph? You should draw more lines. But in theory, the number of lines, the field lines, should be infinity. Okay? Because we can draw many lines around the point charge. But of course, in examination, you should show the comparison. This one only 1, 2, 3, 4, 5, 6 lines. The other one should be double of it, 12 field lines. This one, charge of twice the matrix, represented by twice as many lines. How about this? This one will be the harder question. In the previous one should be the point charge. Only one charge in the universe. But here, in the universe, we have two charges. Maybe unlike charges or maybe like charges. Focus on the first one. Positive and negative. The pattern will be like that. How to know that the pattern will be like that? You should try to set up the case in different position. Then you can know that what will happen. If I put the point charge, it means that the positive one here, then what happened? Positive will positive force. Positive negative attractive force. Then the resultant force should be in this way. It means that this one in this way. But how about this? Positive test charge, positive will positive force. Positive negative will be attractive force. Combine them together. The resultant may be this one. It means that this one in this way. Okay? How about this? If I put it here, positive will positive. Positive negative should be attractive. But remember, it depends on the position. This position, okay, the distance is very far away compared with this. Then what happened? Because the position is near to the charge, the positive charge, the repulsive force should be greater one compared with the attractive force. Finally, the resultant force should be in this way. Then you can find that in this way. Once again, how to construct this field pattern depends on the force, okay, the inertial force produced by these two charges on the test charge. For example, this, the resultant should be in this way. Link up all the or line up all the points, the position together, then we can form these field lines. This field line. At different position, we can have the other field line. Combine all them together, we can form these field patterns. Next case, positive. Then what happened? At this special point X, we will call it neutral point. Okay, neutral point, what will happen? E will be 0. By definition, what's E? Should be force over charge. In order to make it 0, charge cannot be 0. Then force must be 0. It means that at this case, the net force should be 0. But why? Positive will positive force. Positive will positive force. They will same in magnitude but opposite in direction. They will cancel it. Net force should be 0. How about this position? Positive. Then the resultant should be in outward direction. And then far away. Okay? Here, field lines does not cause long bunch. What is the meaning? It means that they cannot do it like this. Here we have two field lines. They can make a course. But why? If I put positive test charge here, it will move in this direction. But when I put the positive charge here, then what will happen? Go to path 1 or path 2? I don't know. So this one tells us that this one is impossible. And how about long bunch? Bunch means that this. Go to this junction and then we have the bunch. Also, we cannot determine this one should be path 1 or path 2. Finally, the final answer is if you have these field lines, it will not cause the other field line. Starting from positive and then ending at negative charge. During this path or this journey, low the other we haven't any the other field line will cause it, or I have bunched it. Okay, the other special case, we have mentioned single point charge, and also we have mentioned two charges, maybe unlike charges or maybe like charges. Then how about the other case? Will be the last case, the parallel plates. Okay, here we have two parallel plates and then connected to EXT. Once again, what's the EXT? To make the object have charge. Okay, this one, red one will be positive where we like to attract electron. So all the electron on this plate will be attracted by this EXT. Only the positive charge will stay here. Finally, this plate will be positively charged. On the other hand, this one is the negative terminal. Negative terminal will attract the positive. It means that it will give out electron. Give out electron to this metal plate. Then finally, this metal plate will be negatively charged. Then what will happen? The diagram will be like that. Positive terminal, make it positive. Negative terminal, make it negative. And also, it will set up field line. But why? The same case. If you put positive test charge here, positive repel. But once again, we have the other positive. This one positive repel. Positive repel. And then you can find that due to symmetry, they will cancel each other. But the assumption is this metal plate extends to positive infinity. This plate extends to negative infinity. Then we can think that everything in upward direction. For example, this one, affect it maybe this. The other one may be this. Everything in vertical direction will be cancel each other, except the horizontal one. Finally, the horizontal one, the component combine all them together, will be the left force. All the left force should be in horizontal direction. Finally, you can see that all the field lines should be parallel to each other, except the edge. This edge, we will say that edge effect, because we cannot have infinity width of metal plates. Okay, this one will be the particle case. In it, the curve will be bent outward. Okay. The other part, we can say that uniform. Uniform means that they will parallel to each other, and also the separation between them should be even. Okay. But what's the meaning of should be even? If I put unit area here, okay, you can see that two lines pass through it. If I use the same unit area at the other position, we have the same result. Two field lines pass through it. Then we can conclude that at different position, they will have the same number of field lines pass through it. Indicates that at any position between the parallel plates will be uniform. Uniform means that constant electric field strength. This one will be the very special concept in parallel plates. This one, okay, direction of the field lines same as the force on positive Q. If this one is negative charge, opposite in direction. And this one explains that what will happen. Okay, initially we have positive plates, then it will form up this field, but this direction is wrong. Okay, so be in this way. I put positive, then it will repel in the other direction. For the negative one, it will attract. I put positive, attract. Okay. This direction is wrong. This direction is wrong. Okay. And then combine them together, what will happen? This part, opposite in direction, cancel each other, zero field. these two combined together, C will fill. But here, both of them should be the same direction. In this way, will be the resultant. Okay, then this one we will say that superpose, add them together, reinforce, it means that greater than before. Cancel out, it means that 0. This one is the special case for the parallel plates. Outside the parallel plates, there is no inertial field. Okay, but between it will be greater one. This one, inside uniform, outside very weak. And now I want to explain that what is the edge effect. If this one is not infinity, we can find that this field line. But why? Okay. If I put positive here, positive dash charge, positive repel, positive negative attract in this direction. But you may think that why this line is not a straight line, it's a curve. Because in some cases, other than these two parallel plates, we may have the other source. This one may be positive or may be negative or may be neutral. Usually, the object will be neutral. Then what happens? If I put positive charge here, this one is neutral object, negative charge will be induced here. It will produce attractive force to attract it to here. Then this one explains that why this field line will be curved outward and then come in. Okay, this one we have the other force acting on it. At the same time, how about the uniform inertial field strength? Here, the same unit area, we have two field lines. But now, if I put the same unit area here, maybe only one, then we can say that due to edge effect, it means that this curve, here the field strength will be weaker than inside. Okay, inside may be E log, then due to edge effect at that position, E will be smaller than E log.